Hey guys, welcome back to the channel. So today we'll be solving another leetcode question. This is wiggle subsequence, and this is another of those greedy questions, which we are getting recently in leetcode. So this question asks us to do is that it will give us an array, something like this, and it basically describes a wiggle sequence. So it's basically something like this. So if you have a sequence, let's say one, then two, then let's say zero, then five, right? Then three, maybe then seven and 2 again. So if you have this sequence, this is a wiggle sequence because you can see differences. If you can compute this difference between these are 1, these are what, -2, these are 5, these are again -2, right? These are 4, these are -3, right? So these differences are always like going from positive to negative, right? So this is positive, then this is negative, then again this is positive, and it goes on like that, right? So if the sign of the difference varies like this, then it's a wiggle sequence, right? And these do not need to be equal actually. So even if I have, let's say, a 4 over here, so instead of 3 I have a 4, even that works, right? So this would be what? This would be -1 to -2, and this would be 3, right? So even this would work, no worries, right? So this is what a wiggle sequence is. So now what it asks us to do is it will give us this array, all right? And what we have to do is basically from this array to tell or we have to tell the or we have to return the value of the longest sub array that has this wiggle sequence sort of thing. Okay, so yeah, so this is all we need to do. So now people who are acquainted with sliding window techniques, they would immediately tell that okay, we have an array, we have been asked for a subarray, and we have also been asked for a number, right? And we have been given a condition that the sequence has to be bigger, has to be bigger sequence, right? So this is definitely sliding window question, but that is not the case. So the greedy question, and I'll tell you why. Okay, so again, if you think this is a sliding window question, as I did initially, so you'll notice that you have been given a condition though, but this condition is not really concrete, right? Like you cannot mathematically form this into a general statement which you can check for each and every value of I and j, right? For the new element in the window or whatever. So you cannot do that. So if you try to do that, even you'll notice that this is not really possible to do that easily. So a better approach would be a greedy sort of thing where we just compute the peaks and valleys. The approach that I'll show you right now. All right. So just took a array over here, just for example, right? So this array I took as 1, 17, 5, 10, 13, 15, 10, 5, 16, and 8, right? And I also made a graph out of this just to visualize the things. So how do you know the sequence is wiggling? So as soon as you see these peaks and valleys, so this is one valley, this is another valley, right? This is another valley, and these are peaks, right? So this is one peak. Let me use a different color. This is one peak, and this is one peak, and this is another peak, right? So when you see these peaks and valleys, you can definitely figure out where is the maximum, where is the minimum, and not only that, you can also figure out the sequence is wiggling. Why? So if you consider this part, okay, so if you consider this part, this difference is always positive, right? This difference is always negative. Okay, again, this difference is always positive, so you can definitely get a sequence of 4 length from here, right? If you consider this part, now this sequence is increasing, this is increasing, right? So we cannot get it from here, but again, see, this is increasing, this is decreasing, and this is again decreasing, so we cannot get it from here as well. But if you consider this part, decreasing, increasing, and then again decreasing, right? So if you consider all these things, you can definitely get one from here, right? So how are you supposed to compute this? So whenever we encounter a peak, so in this case, right, we'll make the number of peaks as number of valleys plus 1. So initially we'll start with we'll start essentially with what, one peak and one valley, right? So in here, this index, up till now uh, we haven't seen any peaks or any valleys, so we'll consider that this is the peak and this is the valley, right? So when we go over here, we can consider that okay, so this value is greater than the previous value. This has to be a valley, not a peak, right? So this, so how do we know, like how do we compute the values and number of values? We don't just add it up. We do it value, let's consider it v, right, equals to peak plus 1. So let's say p, sorry, let's do it the opposite way. Peak would be value plus 1, right, because this is the peak, not the value. I just mentioned the opposite thing. So yeah, if it is greater, then we know that this is a peak, right? Like this might be a peak, not this is a peak. So yeah, we just do this. Now why this? We'll notice that when we reach here, right? So next, when we come here, now here my peak is 2, value is 1, as I mentioned. So here my value will be peak plus 1 again. Similar logic. I'll tell you why we are doing this. So you'll notice that when we reach here and these points. So yeah, again we do this. Now when we reach here, so value is what? Value is 3 now, right? But you will say values are 2 only. I didn't get 3 values. So we'll see why we got 3 values. So if you come over here, if you now notice, what is the peak? Peak will become what? P plus 1, right? So peak will become 4, right? Peak will be 4 over here, but values would be 3. Now you can see this is definitely a value, right? This is not a peak, right? But even though peak is 4, the value is, we have computed the value correctly, right? Then if you go over here, value will remain 3 and peak will be what? Peak will be again 4, right? So even here peak will be 4. Does that. So if you go on this way, you can definitely say at the end, at here, you'll have at least peak correct or value correct, right? Any of these two will be correct. Both might be correct, may not be correct, but any of these two will be correct, right? So if you take the maximum of these two, you can find out how many maximum like alterations we'll be having, right? So let's just continue the algorithm for now. So here again, peaks will be 4 till here, right? Then when you reach, now this become a bit messy. Let's just move on. So here my values will be 5. Now here again, when I reach, value will remain 5, remains 5, right? Here when I reach at value, peaks become 6, right? And now at the end, the values become 7, right? Now if you notice, what did we just compute? We computed peaks as 6, values as 7. This is my final answer, right? Now if you notice, there are total seven alterations, right? So this is one alteration. Let me use another color. This is one alteration. This is one alteration. 3, 4, 5, 6, and 7, basically, because we are computing this as an alteration as well, initial one. So yeah, so these 7 alterations we have, right? And the answer is what? Maximum of these two, so it will be 7 from here, right? So now you can definitely say that okay, one of these two would be my answers, right? So this can be a vehicle sequence, like maximum length will be 7 only, right? So yeah, this is the answer, but there is a catch. Let's say somehow this entire array is a vehicle sequence, all right, but we're getting only one. So how do you mention that? So let's consider an array. First let me clear some space. All right, so now let's consider this array. Okay, 1, 2, 3, 4. I'll take just 5 elements because why not? So yeah, so let's consider this array. So I have 1, and I have 2, right? And I have 3, 4, and 5. Let me color it using some other color. Right over here, this is 1, this is 2, right? This is 3, this is 4, and this is 5. Let's say this went a bit up, but let's not consider this one as of now, right? This is not the, let's say, okay. So yeah, this is 1, this is 2, this is 3, 4, and 5, right? So these are my points. Now if you notice over here, we have only one this thing, right? So this will definitely give us only one, right? This will never give us more than one, right? We can get two though, but that is not what we need, right? So my answer should be what? My answer should be 1 only, right? So here, what I'll be doing is I'll be taking the minimum of the size of the array and the maximum of the values and peaks as I mentioned. This is 1 over here. Here, when I reach, values will become 2, values will remain 2 all over, right? This will definitely return me 2. And if you notice, 2 is my answer, right? This is 1 and this is 1. So 2 is my answer. This is why we'll take the minimum. Now, there might be some confusion. Why minimum? The minimum is just so that we can like remove some corner cases. There might be some corner cases where the size of the array is itself smaller than the values and peaks that we're getting. Right? The values and peaks might even exceed the size of the array, but we cannot go beyond that. So yeah, that would be minimum of those two, right? So yeah, I think that is good enough for now. And let's now talk about time and space complexity of this algorithm. So firstly, what we are doing is we are iterating through the array, right? So we're iterating through the array. Now, how many times we're iterating over it? So firstly, what do? We compute the peaks and valleys, right? So for that, we need to iterate only once, right? And we also compute the size. I think given the language you use, you can use compute the size in O1 time, maybe. Because in C++ we have the size like element you can take, right? We have size function of the vectors, but yeah, that is definitely like possible to do. But let's now consider that we are computing size and sprint time as well. So even then, the time complexity will be O of n, right? Because we are only iterating to the array exactly once, even in the worst case. Now let's talk about space complexity. So are we using something other than the array? We're using two variables, one for peaks, one for valleys, and one for size. Three variables actually. So no, we are not using anything other than the array. So space complexity should be 1. And this is all about the time and space complexity. With that said, let's now jump onto the code and see how to build something like this. All right. So now let's first take out the size of the array. Right. I'll take the peaks and valleys in here itself. Right. Now with that done, let's now start iterating for like the whole array. I'll start from the index 1 or the first index, just because I'm computing difference as well. I'm comparing the two, not difference. I'm comparing the two elements, right? So if I don't have one index less, I'll always run out of bounds. So I have to take one index less for that. Now what do? For each iteration, I first check if the nums of I, right, this is greater than the previous element, right? This is true. Then what do? I increment peaks, right? What do I make it? I make it peaks as value plus 1, as we discussed earlier, right? Otherwise, my next condition is actually if it is less, right? Because if they're equal, we don't want to do anything, right? So nothing will be incremented or decremented if they're equal. But if they're greater or less, we'll increment the peaks and values accordingly, right? So this is what we'll do. And yeah, that's it. So now we'll just go on, return the minimum of size and maximum of peaks and valleys, right? So yeah, I think that should be good enough. And yeah, as you can see, it's pretty efficient. I actually got runtime as 0 milliseconds, but that's fine. So yeah, if that helped, do like and subscribe. And yeah, stay tuned to the channel as well, because I'll be having some great content arriving pretty soon. Thanks.